Alright guys, welcome to my next tutorial. Today I want to look at insertion algorithm, insertion sort. Insertion sort is one of the algorithms that is being used to sort a list of numbers or whatever list you're interested in sorting. I've seen a couple of programs online that shows the implementation of insertion sort. I'm always confused at how somebody was able to reason and think about such a program. And I'm sure there are people out there who, when they see the implementation of insertion sort in code, they wonder how did it just come about that. So that is essentially what I'll be looking at, how you can reason with an algorithm and be able to translate it into a code. So first, there are two parts to it. First is to understand what is the concept behind the insertion sort without even writing any code. Then the second part will be how can you translate the concept, the manual way of doing it, the way you can solve the problem manually, how can you translate it into a code. Many times it is not just obvious how you can translate from manual way of doing things, your manual way of solving the problem into decoding into a code. It's not that obvious and it's not direct. So let's look at insertion sort for those who are new to it. Here we have a list here from 89 to 17, and we want to sort this list in non-decreasing order, that is essentially in ascending order. So you have from 17 to 90. Okay, now the way insertion sort is conceptualized is that you assume that your list is in two parts. One part is sorted, the other part is not sorted. Then you will be taking one element at a time from the unsorted list and you will insert it into the sorted list such that the sorted list remains sorted at every time. That is the intuition behind insertion sort. Now, in preview to that is to look at the edge cases, and one of the edge case is when you have a list that is empty. If you have a list that is empty, essentially you don't need to do anything. Similarly, when you have a list that contains just one element, let's say you have just 89 in your list, then you don't need to do anything because 89 is sorted in itself. Alright, so that is the base cases that you have there. Now if you look here as it's represented, and I'll quickly just walk through what is happening here. You have this marker, this line separating between the sorted list and the unsorted list. Since you know that just a single element is sorted, so the one on the left is sorted and the one on the right of the marker is the unsorted list. So you start from the first element of the unsorted list and you keep picking each element on the unsorted list and start adding it into the sorted list such that the sorted list remains sorted. So for instance, we take 45 and we pick 45, you check the element in the unsorted list. 45 you compare with 89. You see that 45 is less than 89. That means 45 is out of place. Therefore, you need to do what? You need to swap 89 and 45 such that it will be sorted. So that is what is done here. So for 89 jumps from this place and it occupies the place that 45 was occupying, and 45 now replaces where 89 was. Now you go on now to the next element, which is 68. When you pick 68, you compare with each element, 68 and 89. You see that 68 is less than 89. That means it's out of place. Then what do? You take 89 and you shift it to occupy the position of 68. Then you take your 68 again and compare with 45. And you see that 68 is not less than 45. Then you stop. Then you put your 68 in that location. You don't need to shift 45. Okay, then the next one is 90. You continue like that, comparing. In this case, 90 is in the proper position, so you do nothing in this. Then you continue like that, let's say until you get to 17. Then you pick 17, you compare with 90. You see that 17 is not in its proper place. Then you shift 90 to jump into 17. So essentially it means the space that 90 was now becomes empty, now becomes vacant. Then you take 17 again, compare with 89, and you see that it's still out of place. You shift 89 to occupy the vacant place. Then you have a vacant before where 89 was. Then you take 17, you compare with 68, and you shift 68, compare with 45, you shift 45 forward, compare with 17, you shift forward, compare with 29, you shift forward. Then there's no more element to compare again. Then 17 comes to the vacant place. If you look at it, you see that each element is start to jump, like shift forward into the vacant space in front of them. So we now have 75 occupy the vacant position. So that's essentially how insertion sort works. Now let's now look at how we can now write this using a code. So I'm going to now write a programming code in Python to be able to implement this function of insertion sort. So I declare my function as insertion sort, and now you see that my insertion sort takes an input, which is the array. So that means I need to have an array here, and my insertion sort is going to return an output. So return, then what is it going to return? Now, because I'm trying to explain how we think as a programmer, look at, for instance, when my array A is just containing empty or just one element, do I need to do anything? No. That means I can just return back A. In that case, I don't have to do anything. So I can just return my A. Now, when do I have to do something? I have to do work. I have to do a work essentially when I have more than one element in my list. So then I will say if the length of my list is greater than 1, then I will have to do some stuff here. So I'll have to do something here. So I have to do something in this place. Okay, now, so how do I now proceed when the length of my array is more than 1? If you look at the way we walk through this problem manually, you see that we are actually moving from the second element onto the last element in the array. That means I will need a for loop that is going to move from the second element, which is represented by 1. So I have for I in range from 1 to the length of A. Okay, I hope you understand that. So I need an index, a variable that will help me to track like a pointer to each element, starting from the second element, and the second element corresponds to 1 because Python is zero indexing. So if I go through this for loop, then I will need to do stuffs inside this place. So I will need to do something here inside this place. So what do I have to do in this for loop? Now in this for loop, while going through, what I am essentially doing is, at every point in time, I take this the second element, which is represented by my high, and I compare it with the element that is sorted, which is the previous element. So I compare 45 with 89, then I do something. So that means what I will do is, I will have to do, if it is just one comparison, I can just say compare 45 with 89. But look at here, when I have 17, I have to compare 17 with 90, 89, 68, 45, 34, up to this place. And the reason why I keep doing that is because 17 keeps getting to be less than each of those elements. So in that situation, that means if statement will not do what I need, then I will need a while loop that will go from here and do the comparison onto the beginning. Then I will say y a, which is ai, which is the current element, why it is less than the immediate previous element, that is the immediate element before it, then I will have to do something. So I will have to do something here. So then I have something to do inside this. And what is it that essentially I'm doing when this is less than this? What I'm essentially doing as you walk through is, I am just swapping this and this, 45 and 89. So I will just swap them, make sure 89 jump into the space of 45 and 45 jumps into the space of 89. Now to be able to do swapping, so I can just say, okay, what I'm going to do here is I have to do some swapping here. So I have to do swapping here. So I'll come back to how we implement the swapping. Now, once I continue to do the swapping, you will discover that if I just go on straight with this while loop, and after I've implemented this swapping, if I don't have a way of changing these values of I, then once this one has just done one comparison, then that's all. It just comes back here and check, is I still less than I minus 1? No, I've already swapped it, then it stopped. But that's not what I want. That would just be sufficient for just for one swapping. But I need swapping all through down to the end. Then that means I need to have a way of updating my I so that it will get to the end. So I update my I by decrementing my I, so that by the time the while loop, the while loop runs the first iteration, it will come back to this statement. Then my I will become I minus 1, and my I minus 1 becomes I minus 2. Then it does the swapping again. Then it comes back and my I has now become I minus 2, and my I minus 1 becomes I minus 3. I hope we get that logic that is happening here. So that is like shifting backward, going backward, comparing the two elements. So it's like here, you compare 17 and 90, then it is less. Then my high has shifted here. My high was already 17 before, I minus 1 was 90. By the time it does the comparison in the first iteration and does the swapping, my I will become what? 89, and my I minus 1, my I will become 17 because it has swapped. So 17 will come to the place of 90, 90 will go to the place of 17. So my I will become 17 and my I minus 1 is 89. By the time it finished that swapping and it comes back, then my I will become still 17 and my I minus 1 is what? It becomes 68. Then it continues like that until it reaches the end. Okay, now something that you need to look at here is what happens by the time I get to the last element here. When my I is 17, I is now at the position of 34, and 29 is now my I minus 1. Then you compare 17 and 29, then you swap it, then 17 comes to the position of 29 as we have here, and 29 comes there. But then my I will still decrement, my I will still decrement, and by the time I come here, then my I is going to become 0, and I minus 1 will become minus 1, and that is an error. That is an error. That is not what I want. So how do I undo that? It means that I need to modify this condition here so that this can stop when my I is 0. So I need to modify the condition and say while I is greater than 0 and this is true. So these two conditions has to be true. If not, this is going to continue to do the comparison. And I want somebody to look at that. If it is in Java, essentially we now have if it's in Java, possibly have an error when I have a minus 1, but in Python I can actually get a minus 1, which is going to give me the last element of the list. So but that is still an error. That is not what I intend to achieve. So I hope we understand why we have this I greater than 0. So most time when you just see it in program, you're just like, how did they just come up with just putting this condition and everything is just fixed and everything is just put together and it's just working? That is the reasoning. So if you don't have this condition there, then you're going to run into a problem when you get to this place. When you get to this last year, because 17 will also be comparing with something that is not existing, and that is an error. So in order to avoid that, is you have to make sure that I is greater than 0. That is, as long as I is 1, you can, this one will be 1 and this one will be 0, and that is the last one. But immediately I becomes 0, then this will become false. This condition will become false, because once I is 0, then you don't want to say a of 0 and a of minus 1, which is not reasonable. Okay, fine. So let's now go back to our swapping. Now swapping is essentially very simple, but it's trickish, and it's part of the programming construct that one needs to learn. And what you just need to do in order to swap is this. You look at, you have two elements, 45 and 89. You want 45 to go to the position of 89, you want 89 to go to the position of 45. Now there's no way for you to just write one statement and just swap. Then you need to have a temporary variable. You need to have a temporary variable that is going to hold position for you. So if you want 45, 89 to come to the position of 45, so what you're going to do is you're going to declare a temporary variable, and you're going to make that temporary variable and store your a of I inside there. By doing that, you have kept a copy of your 45 somewhere in the result. Then you can now change the value of your a of I. Whenever you need to do swapping, essentially you will take the one on the right and now assign it to a new value. By you assigning it to a new value, you have written the value inside here. So what are you doing? You are now taking a high and you are replacing it with ai minus 1. At this point in time, these two spaces, these two cells has become 89, 89 because you have overridden the value 45 with 89. That is the index of your I. It has now been assigned with ai minus 1 with the previous element. So it's now what? 89, 89. So now what you now need to do is you can then now take your a high minus 1, that is the position that is vacant now, and you now assign it to your temp. And so that is essentially how you do the swapping. So by doing that, you have swapped the two lines of code. All right, so if you understand what we have done so far, that is fine. But then the point now is, if you look at this very well critically, you will discover that we will run into an issue with this high here. Because what is happening is this I index is responsible, you can just say it's a tracker of the position of the unsorted list. But then you need this I to be able to do the manipulations that we need to do here. And once you have already altered this I in this manipulation, then we have distorted the essence of I, the responsibility that I is supposed to perform. That would have been distorted by altering the value of I in this list. So what do we do? Essentially, I is supposed to just be incrementing 45 like we have here, 45, 68, 90, 29, 34, 7. That is the responsibility, the work that I is supposed to be doing, and that is what is doing in this for loop. But we need that index to be able to do some manipulations here like we have done. But then once we have altered the value of high in these places like we have here, then we have altered this work of incrementing one by one. So how do we achieve that? And that is part of why we need to look at this critically. So one way to be able to solve the problem is you need another variable. So we will need to introduce another variable. And what do? We introduce a variable here so that that variable will now be the one doing the work that I is supposed to do. So we can now say, okay, let's change this high, change it to another variable j, and let's make the variable high to be equals to j. You may need to pause and think about that. You need to change this variable into another I into another variable that will do the work of tracking essentially. Then we can now have what? We can now have our I to be equals to j. So we now have our I to be equals to j, and by so doing we are able to solve the problem of altering the value of I. By so doing we are able to solve the problem of altering the value of I. So let's run our code and see what we have been able to do. So I'm going to save this and say this is insertion sort, and save it as insertion sort part 3. It's insertion sort, let me save it as 4, then .py. So that's our insertion sort. So we can now run this program, and let's introduce some values. So we call this print, and we have our lists. So we call the insertion sort, and we have a list. So inside this list, so let's say we start with just an empty list, and let's see that, and we run the code, and let's see what we have. So let's say we have this. Now this is Python insertion sort 4.py. so we run this. So because our list is empty, so it's returning an empty list as we expect. So let's change the list and make it just one element, and we save that. So we run it. So it's just giving us one element as we expected. So let's make sure that we now have 2 elements in our lists. And what do we have? So is sorted 2 1, and now we now have 1 2. So that is essentially what we have. And if we want to try out what we have in this place, we may want to try that out and see what it gives us. So let's see what we have. So if we try out 89, 45, 68, 90, 29, 34, and 17. So we try that and save it, and let's see what this gives us. So we can see and compare our result that we have what you're supposed to have: 17, 29, 34, 45, 68, 89, 90. Thank you very much for listening. I hope this tutorial has helped somebody out there. Kindly give us a comment, and if you benefit from this tutorial, please do give us a like, and if you don't like the tutorial, please do give us a dislike. All this will help us to improve in subsequent tutorials. Thank you very much.